And that's what climate change is about. It is literally, not figuratively, a clear and present danger.
We are in the beginning of a mass extinction.
The ability of CO2 to do the heavy work of creating a climate catastrophe is almost nil at this point.
The price of oil has been artificially elevated to the point of insanity.
That's not how you power a modern industrial system.
The ultimate goal of this renewable energy, plan is to reach the exact same point that we're at now.
You know who's tried that? Germany. 7 straight days of no wind for Germany. Their factories are shutting down.
They really do act like weather didn't happen prior to 1910.
Today is Friday.
It is indeed Friday. Once again, we have Climate Change Roundtable. This is number 77 in a series. And today we're going to talk about hurricanes, or hurricanes to be. And with us today, we've got our usual suspects, Linnea and, of course, Sterling Burnett. But with us also are hurricane experts and forecast experts, Stan Goldenberg and Joe Bastardi. Welcome, guys. We appreciate you coming on today. We're going to get to you in just a couple of minutes, but first we want to do our regular feature, the crazy climate news of the week. Let's start off with our first crazy climate news. Hey, get this. After all of the media said, it's climate change, it's climate change, it's climate change, about the fires in Hawaii, well, Maui County is suing the Hawaii Electric Company, alleging negligence for utility-caused wildfire that ravaged Lahaina. Take that, Seth Borenstein! Idiot. Anyway, sorry, I'm getting a little upset. I hate it when the media jumps on climate change before they even bother to look at facts.
What's funny about all this is how quick the government is pivoting from climate change to private industry and completely skipping over the fact where they didn't have water and fire hydrants. They didn't set off their emergency alert system. They haven't maintained the grasslands that they allowed to grow up with non-native invasive grasses. In other words, everything that they're at fault for, all their climate spending that didn't go to any of emergency management, but they're not at fault. It's first climate change, and now it's all the utilities' fault.
Well, even their diagnosis of the situation was wrong. Even though Dora was a Category 4, it was a pinprick storm. It was no more than 100 miles wide, way to the south. And the National Weather Service in Honolulu nailed the trade winds that were coming Tuesday night before. They had damaging winds out. I read their stuff because we have, believe it or not, we have a client that's towing a barge out to there. So I watch what's going on in Hawaii all the time. And even that, we had a Category 4 hurricane go to the south, that being blamed, shows you how vapid and shallow the research is in what I call the meteorological misinformation media. They just spout out what's there, so the hurricane gets blamed. And the hurricane had nothing to do with it. It was the strong trades drove the hurricane way to the south, which happens a lot around Hawaii.
Yeah, anyway, so once again, as usual, the media was wrong. All right, let's go to our next one. Climate change could make migraines rougher for some. Ugh, gosh, just looking at that headline gives me a headache. I mean, what doesn't climate change cause these days? I mean, it's literally the center of the universe for cause for everything. Ugh.
Well, they weaponize it. I was in a meeting the other day. Guy blamed the increase in asthma in Western Pennsylvania on fracking. Right? I'm like, well, it's like, because they want to hit that industry too, by the way. I tell my natural gas friends, I go, as soon as they get this one out, they're coming after you. But they'll blame anything.
Yeah. They'll blame anything.
What were you going to say, Linnea?
Well, I was going to say that I think we can all agree with this title, that climate change, or at least climate change coverage, causes a whole lot of migraines in this crowd over here. So
you stole my line there. Climate change coverage gives me.
Oh, wait.
Every week on Climate Realism, we all suffer through headaches pushing back on all of the insanity from the media.
I get to bring some reality here. Climate is always changing, and climate changes do affect some of these things. But the issue is it man-made or anthropogenic climate change. That's the real issue. I'm a climate scientist. I always deal with the climate changing.
Yep. All right, let's go to our next crazy one. We've got plenty. Speaking of things in your head, climate change is changing how we dream. Yes, that's right. It's reaching right into your brain and making you dream things.
I didn't hear this one. I never heard this one.
As Jim Lakely said a couple of weeks ago when we first looked at this article, it is getting impossible to parody the climate change narrative. They're doing it themselves.
Well, this was the guy that Babylon Bee was. I heard about Glenn Beck yesterday. Was saying like, I can't believe the stuff we were parodying 2 years ago is now out there. I mean, the problem is that you got to, I'm right here at Penn State, in the college, and I mean, you got kids that are indoctrinated, don't think about a thing, and everybody just buys what they're being told. That's amazing too, because I'm 68, so I'm from that generation where you suspected everybody and anything, and somehow or the other that generation now takes power and doesn't want you to question anything. I never heard this one. This one really, dreams are changing, huh?
I still sometimes dream vividly, not as much as I did when I was younger, but still do. But I have yet to have a dream where hurricanes or droughts or tornadoes or any sort of weather event, heavy rainfall featured prominently in that dream. So I'm wondering how it's changing how we dream.
Well, I'll tell you what. Oh, I'm sorry. Go on, Linnea.
No, it's all right. I was going to say, yeah, I haven't. I was just thinking about it and reading that first paragraph there. It seems like they're dreaming about climate change because they're working in the climate change media area, and I just reflected on. I've never had a climate related dream whatsoever, despite the fact that I've been working in this area for a couple of years now. But I have had dreams and nightmares about like volcanic eruptions and stuff. I used to have that every once in a while when I lived in Laramie. But
but volcanic eruptions are climate change, so you have had climate.
Well, that's not they cause climate change. I don't know if you. I've seen it in the media.
Yeah, it's not saying the media tells me that it's they're causing.
Well, maybe I have.
You guys remember that senator came on and said, my 13-year-old is having nightmares about climate change. You remember she said that? I had nightmares about that too. I was always dreaming that the storms that my dad were telling me that were going to come wouldn't be as bad as what he said they were. Like I was exactly opposite. I wanted them worse. He said, hey, we're going to get a foot of snow. I want 18 inches. Hey, there's hurricanes passing 100 miles offshore. Dad, can't we get it in a little bit closer to Atlantic City? So I could sympathize that people are dreaming it, but I'm so warped. I had the opposite dreams.
Well, my thoughts are if people are actually dreaming about it, if it is actually affecting their dreams, it's sort of the same self-fulfilling prophecy that is causing the psychological problems that they are always talking about.
Yeah.
The media constantly harping on something.
Exactly. Right here, this headline here is the whole thing. Kids are having bad dreams because the media is pushing ridiculous things. Anyway, enough of the bad dreams. Let's go on to our final crazy. Yes, NASA may be running a mental ward. Scientist Kimberly Miner. I'm a NASA climate scientist, and here's how I'm handling climate grief. Speaking of things that are all in your head, climate grief is also all in your head. Good.
I wonder what she's grieving. It's not the 1970s again?
No, how about if it's not the 1930s? Do they have any? My dad, when I was a kid, you have any idea how bad the weather used to be? I was like, sure, you walked uphill both ways to school in the snow barefooted. But then when I went back and researched it, when I got to Penn State, they had the archives of the maps. I was like, holy smoke, why can't we have that weather now? 2 major hurricanes hitting within 18 hours on the U.S. coast in September 1933. Can you imagine if that actually happened today?
They would go apocalyptic.
Listen, I got a whole different spin. First of all, I had a student work for me, an intern, and brilliant guy, and he was so petrified and traumatized by what the school, this is 10 years ago, telling him about, man-made, then global warming. And so he was so relieved for me to share some of the balanced view of it. By the way, they also told him that no scientists used Apple computers. That turned out to be false as well. But listen, these climate people are actually improving our health. Can I tell you how? Because the Bible says a merry heart doeth good like a medicine. So they're making us laugh. It's so ridiculous when we aren't pulling our hair out over there.
Right. Unfortunately, these people cannot distinguish reality from fantasy most of the time, and that's why we have all of this craziness. They really can't.
It would be laughable, except look,
it's
I've been
so dangerous.
Then they're getting their way. Look how close we are to this. The real tipping point is the whole economy crashing because of the Green New Deal over here. I tweeted something yesterday. I said, the old saying, we'll look back on this and it'll all seem funny. We're going to look back on this and it's not going to seem funny what these people have been doing. I can't even believe what I'm looking at. And that's a NASA climate scientist. No wonder we see some of the adjustments being made. So.
Yeah, I'm going to respectfully disagree with Stanley there. That the few times I laugh at these things, like the Dreams headline, do not overcome the rise in my blood pressure every time I see a new report and a new government agency says, we've got to do something because of this.
Yeah. Speaking of which, I'm on blood pressure medication, so I guess we could say climate change causes high blood pressure.
Well, it's interesting how I've sort of handled this situation in that. I've said this and I mean this. I have gratitude toward the people on the other side because they say something, I go look at it. I used to wrestle Penn State, and you always had to try to figure out, does my opponent have something I ought to know about? I only know what I know. I don't know what I don't know. So therefore, if someone has something, even if it's 10%, even if what he says is 10% I agree with, that might be something that could strengthen me. The other thing is I look at it as spiritual combat. It makes sense to me that they would, arrogant men would try to actually use the control of climate to make you believe that they're like gods and they can save your life. So it just, that does keep me relatively balanced. Remember, I have Sicilian blood in me, and that can be a real problem as far as blood pressure goes.
It's not just arrogant men; it's arrogant women. That was a lady, and so is Catherine Hayhoe, and so many other of these people.
Yeah, I would just like to get in front of her with this PowerPoint I have on what's been going on over the last 50 to 100 years with sea surface temperatures, because we got reliable.
Stanley, you keep cutting in and out for some reason. You're muted also.
Yeah,
I deliberately turned off my camera for a minute.
No, okay. But a lot of people would probably say, let Bastardi talk, but turn off his camera. But I'm saying I would love to. These people apparently seem blissfully unaware of stuff. I'll tell you what gets me worse, and we'll get into this, I'm sure, with Stanley. Gets me maddest is they had this whole trapping hotspot theory. This big trapping hotspot over the tropics. We've gone the opposite way.
Let's get into that when we get into our regular discussion.
Yeah, okay.
But first, I want to introduce both of our guests, Stanley Goldenberg and Joe Bastardi, both of whom are forecasting and hurricane experts. So I want to preface this with some graphics from the National Hurricane Center to kick this off. First of all, the current graphic that we have for Atlantic tropical cyclones and disturbances. Right now, we have Tropical Storm Franklin, which actually formed quite some time ago, several days ago, and is still churning out there in the Atlantic. That has the potential for making landfall. We also have some other potential tropical disturbances, but over the 7 days ahead, we do see Franklin continuing. We see the potential for a new system forming around the isthmus of not the isthmus of Panama, but the peninsula there. Anyway, so we see potential one hitting the west coast of Florida. And then a couple others out on the central Atlantic that are likely to go north and not disturb anyone. So there's that. And then we also have the tropical temperatures, which are quite warm. This is from WeatherBell. This is a sea surface temperature map. And although the scales cut off, the browns that you see there in the Pacific and in the Atlantic are in the 30 degrees to 31 degrees centigrade range. The next graphic shows the United States on the close-up, and it shows quite a bit of warm water throughout the Gulf and also in the North Atlantic. So we have the potential for fueling tropical storms and hurricanes, and there's been a lot of talk in the media about this excessively warm water is going to create, it's just basically going to supercharge these storms. So what do you guys think about that? First, I'll let Stanley lead off, and Joe, you can provide rebuttal or agreement, or your choice.
Okay, well, first of all, let me say that the SSTs in the Atlantic, I never look at the actual sea surface temperatures to really understand what's going on climatologically versus other years. We look at the anomalies. It's not unusual for the sea surface temperatures to be warm right now, but are they anomalously warm? Are they warmer than normal? And the Atlantic, although was really, really excessively warm, much warmer than normal a couple months ago, that has cooled down a bit. It's not quite as extreme as it was. But the key thing to understand with the sea surface temperatures, and this is what a lot of the global warming fanatics don't understand, it's not just the ocean temperatures. It is also the atmosphere. So you can have waters. We've had years where the sea surface temperatures in what we call the main development region in the Atlantic are piping hot, doing great, but you have excessive, what we call vertical shear, the difference between the upper and lower level winds that just will not let these storms develop. And in fact, I have to say, I reviewed a study years ago where what they did was they said, what would have happened with Hurricane Sandy in 50 years from now, what the models say the sea surface temperatures are going to be. So all they did was change the sea surface temperatures. They took everything the same and then just warmed everything. They didn't change the atmosphere. If you change the atmosphere, what those same models say, it might have been weaker. So it's not just the sea surface temperatures. And in the Pacific, those sea surface temperatures are part of the El Nino event that's happening now. And that is actually decreasing suitability for development in the Atlantic. And it seems like those conditions, which it increases that vertical shear, are creeping into the Atlantic bit by bit. In fact, if you read our NOAA seasonal outlook, which we update in August, it's the battle of the basins. You have these super warm waters in the Atlantic and then warm in the Pacific, which was a totally different effect. And it's like, which one is going to win?
Yeah, which one is going to win? Joe, what do you think?
I have I've been pushing this distortion of temperature pattern for about 10 years now. And, this comes from a very basic idea taught to me by my dad that tropics and hurricanes are nature's way of taking heat out of the tropics, redistributing into the westerlies. And if there's no reason to do that, why do you need a hurricane? And that's why you're seeing these things. Everybody got bent out of shape in June. We had 2 African waves try to develop, got chopped apart, of course, further west. But now we are at the height of the hurricane season. Nothing can move west. Everything that tries to develop just starts moving north. Now, why is that? I've shown this on Weather Bell and Twitter. The mean sea level surface pressures are exactly opposite of what you want to see. You have low pressure extending from the eastern United States, which, by the way, has something to do with why the waters west of Florida got so warm, because you had a reduction in the amount of southeast winds, so there was more westerly component to the wind, allowing warm water to build up there. I'll get to that. But when you have low pressure to the north, the convergence of a storm naturally spreads out. Eric Blake once famously said, hurricanes are delicate creatures. They need almost perfect conditions to go on. And you saw that. You remember the wave that went through the Gulf of Mexico? The way we were talking about that Weather Bell when it was just a dust surge. We warned our Texas clients it was going to develop because it was going to break the shearing trough over Florida, get out to the other end. But you notice how when it got into the Gulf, the clouds were all spread out. There is so much warmth around that there's a competition for convergence. You saw that last year. Until you got to the seasonal cooling, the hurricanes would not go off. The fact of the matter is you need cooler water and you need higher pressure to the north to help incubate the kind of focus of energy for these tropical cyclones to develop. So the big key to this year, we had only a normal year this year. And you're seeing what's going on. I keep telling people, I go, we got 9 named storms and a total ace of 21. And if we had not had the phantom storm in January and Don, both of which that came out of the westerlies, you'd be looking at 1/3 the normal ace this year, despite the hysteria over the warm water. Now, I will tell you folks this, in my opinion, this is what I call a bounce back El Nino. It's due to cumulative buildup of warmth. You had a 3-year La Nina. And some people have been feeding me information about what's been going on the last 30 years in the deep oceans. Okay, so you have this strong bounce back El Nino, but I believe it turns around next year, and that's when you may really see things go absolutely ballistic next year. This year will have its challenges. We've already been targeting September 5 through 20 as a down period relative to averages. but the 20th into October, we think will be a higher period. And I bring up 2002, an El Nino year. 2009, we had Ida hit Louisiana. 2015 was Joaquin. That 2002 El Nino is fascinating to me because for the first time in recorded history, we had 2 Category 4 hurricanes in the Gulf of Mexico within 10 days, Isidore and Lily. And fortunately, they didn't pan out the way some of the modeling has said. Otherwise, you would have had a Cat 4 into Galveston and then a Cat 4 up into Louisiana. But you can see this stuff going on. And I have a big picture view of it that's, mainly comes from my dad and Dr. John Kerr here at Penn State. When he was and Dr. Lee, they were my tropical professors, as to what is the weather trying to tell you. Look all over the place. The West Pack comes up, the Atlantic Basin starts to go down. But the shearing.
I think that, Joe, I want to interrupt a second and say that weather is trying to tell us every day of the week and twice on Sundays. It's weather, not climate.
Yeah. Well, my dad used to say, the weather asks you the question, your forecast is the answer. See, I was so blessed in the father I had. Can you imagine that? I mean, I wasn't a real good athlete. My brother was, fortunately, but I mean, it was just unbelievable. My favorite times in my life were riding out hurricanes with Dad, and then I ridden out hurricanes with Garrett. So it's interesting.
Let's get to Stan again. Now, Stan, you sent up a PowerPoint and you have some slides to show. So if you just want to call out what slide numbers you'd like to bring up, Andy will take care of it.
Ready. Let me just do another perspective on something that Joe just said, because this is research that I've personally done. And that is when we look at the activity overall for the season, especially the early activity before August. One thing I want to say, because if we don't say this, I feel totally negligent, is that anybody who's in a hurricane area, an area that can be affected by hurricanes with the North Atlantic, needs to realize we're in the peak 3 months of the hurricane season, that it doesn't take long for something to spin up. 5 Cat 5 storms that have hit the U.S. in the last since 1935, all of them were tropical storms less than 60 hours before landfall. Some last a long time as strong storms, but these spun up like Andrew 31 years ago yesterday, and people need to be ready. I'm looking at my preparedness. I don't care how busy the season or how slow it is. This is probably the most important thing I can say for the sake of people out there, how busy or how slow it is. It only takes one to hit your area to be a disaster. 1992 with Andrew was a fairly slow year. And by the way, if we have a bad storm, this is my prediction every year. If there's a really, really bad storm, bad landfall, someone will blame it on man-made climate change. So back to the slide is that I don't care how many storms we have in June, July, that has almost no relationship to the rest of the peak season activity, August, September, October, except in that little dashed box, kind of most of that blue area. I call that a special Southeast Main Development Region box. And if you have storms formed in that area in June, July, once you go to the next slide, number 9. Okay, virtually every single year, if you look on the right, since 1995, that has had at least one. It doesn't have to become a hurricane. It doesn't have to stay together. If it becomes a named storm, tropical storm or hurricane in that area, and that column SCJJ shows how many formed in that particular area on these years, most of them were hyperactive years. And other than that, they were all at least above normal years, except for 2013, where all sorts of weird stuff happened. We totally busted our outlook. But that was one of the factors that went into our saying that this is going to be above average year. However, the impinging El Nino impact can make a big difference as well. And by the way, if you go to, can you jump back to slide 2? 2. Keep going. There you go. That just shows how much of the activity is concentrated August, September, October. And if you go to the next one, by the way, this gives an overview of what's been going on so far this year. And just you can see all the activity we have, but very little strong stuff. It looks like Franklin will become a hurricane, maybe even a major hurricane in a few days. It's not unusual for August. But what I see is that apart from that June, July signal, which, like I said, might be neutralized by the El Nino, is that it seems like the years where the main development region is so far not conducive to development, but the storms, when they get to the north, are able to develop.
That's been going on the past 10 to 15 years. And
no. Only in the non-favorable years. We've had plenty of years you've had stuff develop in the main development region.
I have to disagree with you. I've done the research on the ACE, and the amount of outgoing long-wave radiation has increased dramatically across the Caribbean into the Gulf of Mexico because of lack of cloudiness in there. And
let me finish these few first, Joe,
Okay.
if you don't mind. If you look at the top there, it shows that right now our overall activity is just about average. It's from the CSU side. If you go to the next slide, this is something. The left one is something Anthony already showed. The right one is what Franklin looks like it's going to doing. It's a good chance Franklin won't impact land, or might impact land way to the north or in Europe or something like that. But it could reach major hurricane status. And but that's what's happening now. But people really need to pay attention to the hurricane season, what's going on out there. You've got climate and you've got weather. Forget the climate change stuff. You've got climate. You've got the overall activity, and then you got the weather, what's really going to impact you and happen to you. And I'm sure we'll have at least 1 or 2 major hurricanes this year, and we could have 1 or 2 landfall. That thing in the Gulf, just realize the conditions for development in the Gulf are better than to the east. So this thing at this time of year has a decent chance of developing. At this point, they don't know how much it'll develop. They have to see in the next couple of days. By the way, to let you know, the NOAA planes, where I work with Hurricane Research Division, Aircraft Operations Center, are out there flying Franklin right now, collecting all sorts of data. I mean, data that helps the Hurricane Center, that helps the forecast, but also data that we use for research and learn more about hurricanes. Those are some of the most heavily instrumented aircraft in the world, and many of my co-workers are out there right now on those planes and having incredible time examining the storm in every which way. But thank you for letting me share those few things. Go ahead, Joe. Or
well, what I was going to say is, over the last 6 years, all the major hurricanes have developed within 2 days. They've reached their maximum intensity as they've hit land, all in phase 2 of the Madden-Julian oscillation. What I was trying to say to you is that the great long track storms, and this is why I think Saffir-Simpson has got to be thrown out. We have a power and impact scale I've been trying to push for the last 10 years that takes into account radius of hurricane force winds, radius of 34 knot winds, radius of 50 knot winds, to show the overall power of the storm. Now, why did I develop that? Because I have clients. It's just like we've been warning our clients for 2 days, look out in Florida early next week. Why? It's pattern recognition. There's a pattern recognition technique you use. And I actually read about in the 80s about when troughs try to dip into the east, you look over here, here, and here. But it's very unusual, folks, to see a storm in an El Nino year in the Caribbean not running westward, getting sheared apart, and being ripped into pieces and then come out the other end. Or a Central American feature coming north in August. You don't ever see that in El Nino seasons. Why? Because the El Nino seasons have very low pressures west of South America and over northern South America. So the easterlies are normally much stronger. You increase low-level easterlies, you naturally increase shear, right? I mean, Gil Clark at the Hurricane Center used to always watch that Colombian low. When I used to talk to him, he's always said, the wind's blowing 50 miles an hour at Aruba. Guess what? This isn't going to develop. I mean, the guy actually helped formulate a lot of my ideas. So what happens when there's low pressure all to the north, all over the place? What happens then? So you're looking at a very, very unusual season. And my hypothesis is we got to look at the North Atlantic because we have strong deviations from normal in the North Atlantic. This in turn is lowering sea level pressures. And if you spread the sea level pressures out and you change the normal tropical wind oscillations, guess what's going to happen? It's going to impact your storms. You can even see it on the European long range. It's starting to agree with the Weather Bell idea that overall there's a downturn coming between the 5th and the 20th of September, right at the top of the season. Now, what I can't rule out is, let's say this idea, what's it going to be called, Idalia or whatever, gets off the mid-Atlantic coast or something, or off the South Carolina coast and sits there for 5 days. Because I don't like this trough is digging in. It's going to pick it up to a point, but it may leave it behind and then gets lost in the ridge. So you might be able to pile up ace points that way. But I'm much more concerned with this the rest of the season, what starts happening later in the season as cooler air masses. What do cooler air masses do and what higher pressures do over land or in the North Atlantic? They focus convergence. We know that there's a lag of the ocean temperatures, right? So the oceans are warmer, let's say in September and October than they are in May and June, right? We lag it. And since the water temperatures are so warm in the North Atlantic, and as Stanley showed the main development region, my opinion is the main development region now is from 15 to 30 north. This stuff way.
Well, I guess we'll find out in the next month or so whether that's true or not.
Well, it's where the most ACE occurs. And see, that's what Weather Bell does. At the beginning of the season, we say we draw where we think the impact is going to be, and the most ACE part of the ACE index is going to occur. And so
by the way, Joe, I'm the one who developed the main development region. It came out of my 1996 paper, so I know what it is. And if you look, by the way, at slide 5, if he brings that up, it's not where the most ACE occurs. That's not what the main development region means. It's where most of the systems that become major hurricanes first develop, reach depression strength. That is how it was developed.
Yeah, but we haven't seen that.
Wait. If you look at the climate stuff, you're welcome to read my 1996 paper.
I've read a lot of the stuff.
Okay.
I'm just saying, Stanley, if you look at outgoing long wave radiation and what's been going on the last 15 years, I don't know if you've updated this, but I would take a look at it and see the lack of activity down there. And I got a lot of people that are commenting on it because I'm obviously partial to my theory that what's going on is the distortion of the pressure patterns are making the development region shift north. It's more random. A lot of these waves wait for a long, long time to develop, and they've got to get in close to land. Every single one of them, Harvey, Ida, all right, Michael, all right. What was the name of the storm a couple of years ago? It was an ice storm hit Louisiana. Ian, all right. All these storms are developing north of 20 degrees north. The big powerhouses, Florence, Dorian, right? They're all Irene. They're all falling apart as they come toward the U.S. coast. It was funny, with Florence, the Washington Post, this could be a Category 6 hurricane because the water's so warm. It's like the old, remember, this is Spinal Tap. Yeah, my guitar goes up to 11, right? So what happens, all I'm saying is and look, I'm partial to what I was taught by my dad. Those big storms, the Hazels that hit the coast at max strength, Carla hit the coast at max strength, at 44, 38, they're gone.
All right, I'm going to make a timeout here real quick. I want to ask you something. This is a common question I get about Category 6. Is there a need for a Category 6?
Why not go 7, 8, 9, 10? Here's what I propose, that we do a power and impact scale where pressure tendency is in their maximum wind, but the radius of wind. Because, let's take Sandy. Sandy was a major on my scale, did major amounts of damage. You know why? Even though the max wind was 80 miles an hour near the center, it was 85, 90 miles an hour, 200 miles away. Compare that to Charlie in 2004, which was a fist of fury that was no more than 50 miles wide. Or try comparing Ian to Donna, right? I mean, Donna could be the craziest thing. It gave hurricane force winds every state, Florida to Maine. It was a 4.32 landfalling storm.
Alrighty.
I'm like, when do you see that?
Anthony? Go ahead. When he's done.
Stanley, what do you think? Category 6, yay or nay?
Yeah, nay. The first of all, people have to understand why they came up with the categories by Safford and Simpson way back years ago. Herb Saffer and Robert Simpson. And the issue was to have a simple scale to communicate to the public. One of the biggest problems is doing simple messages to the public. And the issue is that it's not even if two storms are exactly the same intensity, depending where they hit, it'll affect how much storm surge you have. Depending where you are in the storm, depends on what kind of impact you have. So they have to simplify it, but then you have to get down to the nitty-gritty of how you're going to be affected. And, believe me, they were strong. Cat 5 is a strong storm. I mean, you don't need something stronger than that to try and define it. They're trying to come up with different things that combine different aspects of the damage. And one of the things Joe was talking about, the issue of, what we call integrated kinetic energy. So you can have a very small storm. If you integrate all the kinetic energy across that storm, it's going to be very different from one that's very, very large. And so that's, you know, I don't
for
see
our
any
viewers, I want to make a point
except
here.
for a good movie. Except for a good movie.
Yeah. For our viewers, I want to make a point here. The warmth in the seawater, the sea surface temperature, and the heat that's stored in the ocean, that's the potential energy for hurricanes. The kinetic energy is actually the hurricanes in process. They are taking that potential energy and distributing it throughout the upper atmosphere and so forth and so on. Essentially, hurricanes are heat distributors. They are normal process to keep the atmosphere in balance.
Neil Frank used to call them the nature's egg beaters. They're Dr. Neil Frank, former director of the Hurricane Center.
Well, that came out of my dad. I said what my dad taught me. So all my argument is with people, and I've been arguing this now for 10 years, the warmer the planet gets, the way it's getting warmer, it's a distorted warming. It's warming more in the north and away from the equator. Guess what happens? There's no need to take the heat out. And so what's happening is you're literally distorting the entire pattern. And we can see that Willie Soon and the Connollys have come up. I've showed that the Hadley cell is completely, say it's completely disappeared. The vertical velocity patterns. And I said, okay, that started me thinking that means there should be increased outgoing long wave radiation across the tropics. And sure enough, the last 10 years, even against the 30-year means, go take a look at the Caribbean and the Gulf of Mexico, all the way to the Central Pacific. These areas are directly opposite of what they were in the 50s and 60s. So and by the way, the other argument for the power and impact scale is I'm tired of people saying, what's a category 4 hurricane? Okay, category 4 Ida. Go against Betsy. Ida versus Betsy. I was in Baton Rouge before we drove right into Hammond to make sure we rode out Ida. And the storm was 100 miles southeast of Baton Rouge, and it looked like a backdoor cool front in Atlantic City, 15 gusts to 25 out of the northeast. When Betsy came in, it drove a tanker all the way up the Mississippi River in there. Baton Rouge gusted 100 miles an hour. They had hurricane force gusts all the way out to Lafayette and all the way east toward Mobile. How is Betsy a Cat 4 and Ida a Cat 4? That's what I'm saying. So when you're seeing this whole missive that storms are getting worse, no, they're not, because size matters also. So while there's no question, man, if you bundle that energy and the water's warmer, guess what's going to happen at the center, right? But you see a lot of dime-sized systems nowadays, as opposed to those great Atlantic hurricanes. Even Carla, I saw a picture of Carla, because Carla versus Harvey. That's another example I made. Carla gave hurricane force winds to everybody on the Texas coast. It covered the whole darn Gulf. I mean,
listen, Anthony, can I respond to a few of the comments?
Let's get to Stan. Stan's got a slide to show us.
Yeah, and I want to respond to a few of the comments. Someone saying no consensus on how to scale hurricanes. No, there is a scale, and that's the Saffir-Simpson scale that we've been using. They're trying to develop other scales that might be more effective, and these are people who know how to deal with the public. But if you put up slide 11, because someone was commenting on there that, so I guess the hurricane activity doesn't have anything to do with the man-made climate change. I just want to give a plug for a talk I gave at the wonderful Heartland Institute Climate Conference in February. I'll tell you, the people watching this, if you haven't accessed some of those talks, you need to go. Those conferences are phenomenal. Do everything you can to go. Is this plug okay, guys? To go to the next conference, they're phenomenal. You see people like those of us on the screen here, many others. But this is a talk I gave in February. You can see the link, simple link, bit.ly/Goldenberg Orlando. And that's why does it seem like hurricanes are getting more destructive? So it really, puts to rest a lot of the wild climate change things that people are saying. So I just want to throw that in there.
Well, it's funny, Stanley. What I did with Hillary was when the wave came off Mexico, because we got clients out there. We got water companies in California. Weatherbell, despite being small, has pretty big clientele. But anyway, I said, here's what we do. Let's pattern it after Kathleen in 1976. That's the benchmark storm. They talk about this 39 storm that went up to the north. So Kathleen did $176 million of damage. in 1976 dollars. That approximately is close to $1 billion now. Plus, when you look at the increase in infrastructure in California, so if Hillary is the storm Kathleen was, it should be a $1.5 to $2 billion storm, right? But what you do is, with your let's say you can identify a past storm.
Yeah, Joe, I want to make a point. The reason that Hillary did not perform is because of Russian interference.
Well, I thought it did perform. Well, you know what I heard? I heard it wiped out emails all over.
Yeah, a lot of documents disappeared.
Look, it performed in the mountains. I mean, look, because I get into arguments on both sides. Like a good friend of mine tweeted, "Hey, we got 15-mile-an-hour winds and heavy rain here on the coast, right?" And they're showing, Senator Hillary's coming right up over top of you. Nothing's going on because of the shadow from the mountains. But meanwhile, you're getting Big Bear Mountain or whatever it is, gusting to 85 and 10 inches of rain. And so when the damage reports come out, and that's what I do, because in the private sector, I'm not, I'm a big, believe it or not, I've told people in the Hurricane Center that, boy, if I were director of NOAA, you'd really be getting some money for research, because that's what I'd like to see. But when you have to let your client know very quickly, like, what could happen here. So what I like to do is, like, for instance, we've got from 25 degrees north, right? Not so once we get north of 25, we have Idalea, or geez, why can't they just make easy names for me? Analog to Hermine in 2016. So right now I'm saying, look, this looks like this could have the same kind of intensity as Hermine. So we're giving people an idea that, and it's right now it's a stratocue, just a swirl there. But when I see outflow developing in the Gulf of Mexico to the north of the Yucatan, it's like putting red meat in front of a rabid dog. I start getting excited. So I think this thing's coming up. What's fascinating, Stanley, I think you'll agree, is no major hurricane has ever hit between, Apalachicola and just north of Tampa. Even the 1935 hurricane was only a Cat 1 when it went into Cedar Key. And there's this whole theory about what happens on the west side of Florida, where the east winds come off, there's upwelling, pulls dry air in. So a storm coming northwest off the Florida coast either gets pulled into South Florida or it weakens coming north. The ones we have to watch for, something starts going northeast and hits the coast perpendicular. And what bothers me about this system coming up is that the entrance region to the trough to the north, the front entrance region is right in a good place to ventilate a northeast storm. So I did want to bring this storm up because we're already.
Okay. Before we go on to the next topic, I want to provide a moment for our two silent partners, Linnea and Sterling, to kick in with any questions or comments they might have.
Well, Joe was talking about cost of these storms and how to rank them, and I'm concerned about treating cost as a way to influence how they're ranked, or just the nature of their whether they're widespread, because costs are related to development, and of course, the more we develop along the coast or inland, but still coastal adjacent in some sense, it's going to be natural for storms, be they category 1s or category 5s, to do more damage. The cost figures, the absolute, the absolute, not the relative cost figures, but the absolute. And so it's not clear to me why the development impact, the insurance costs, or whatever you want to say, should influence whether we rated that as a major storm or not, because it has nothing to do with the actual atmospherics of it. It has to do with the fact that we've developed land.
Well, what I've done and constructed, because again, I have all these clients, is that if I could put together a scale that, for instance, even though Sandy at the center was relatively small, if she does a lot of damage, or she does moderate amounts of damage in a larger area, she is, if you're an insurance company and that's coming, it's a valuable piece of information. So, I'm sort of bridging the gap here. I learned back with Wilma never to make a comment as to what the storm is going to do. What I do is I predict the storm. I like to show past analogs. And if you watch me on Twitter, I said, this looks like this looks like this, so people can see a path, reference the years, so they know we're not blowing up climate change. I mean, these people in California going nuts. I go, well, go look at 1976, for goodness sakes. And by the way, folks in California, you may have another feature or two to come at you this year. I'm not going to say they're going to make it all the way up there like that, but impact you. So what happens is when you're doing that, and you have to deal with the fact that there are human beings putting themselves in harm's way, and that people want to know about that, you try to somehow or the other mitigate. What I'm worried about, and believe me, if you went over this power and impact scale, I bet a lot of these bigger storms would rank less than comparable Saffir-Simpson from years and years ago, because a lot of those storms, like, Stanley, I'm sure, is in awe of the 44 hurricane and some of the details that came out of that in 38. A lot of those storms, they were just hurricanes near the center. These things were punishing people 150, 200 miles away. What did Donna have wind gusts to near 100 miles an hour in Miami, I believe? What was the peak wind gust with Ian in Miami? So those things, they cause a lot of damage.
Right.
My concern with power and impact is it will give us a better objective look at how much kinetic energy, as Anthony brought up, is in the storm versus another storm, so we can figure out how much of this potential energy of the warming is actually being used in these hurricanes.
Sounds like a good idea. It really does. And I hope that maybe you can write a peer-reviewed paper to get that out there, because I don't think the community is going to accept it otherwise, because peer review is their gold standard.
That's the interesting thing, that those are the rules of Queensberry. I'm more of a bare knuckle fighter. I always tell people all the time, what we do at Weatherbell is we real-time test ideas, and sometimes they just fail miserably, all right, in front of people, and then you go back to the drawing board. But, I think it's still a free country, so, I'm blessed that we live in the world that we live in.
Okay, so but before we go on, Linnea, do you have any comments that you want to get in?
Oh no, I'm just sitting here kind of in awe of the amount
You're
of
just having a
memorized
wonderful time.
information or, years of experience and everything that these two gentlemen bring to the table here. I think we could probably reach into the comments for a second. There was a question a minute ago that I think would fit in here pretty nicely. Let me try and find it, and I'll tell Andy which one to pull up.
Under the starred section?
Yes, it is. Well, let's talk about the impacts that Tonga eruption might be having on some of this right now,
right.
if
All
any.
that extra water vapor in the atmosphere.
Right. Bob Johnson at 137 asked, is fake news media reporting on the huge Tonga underground volcano eruption? I think he means underwater eruption spewing tons of water vapor into the air. Do you guys think that would have any kind of impact on this hurricane season?
Honestly, I don't have real data and research on that, but I'm going to keep my ears open, and maybe you'll cover it next week, and I'll ask some of my comrades.
So the basic question here is does an increase in water vapor in the atmosphere translate to a more powerful or a less powerful hurricane? I've never heard that question answered.
Well, water vapor, the water vapor has a huge impact. And I remember I was flying Hurricane Rita in 2005, and I was on the Gulfstream 4 jet, and we were seeing from our instruments there was a huge area of dry air moving in from the west. And I, called the Hurricane Center and said, this thing's going to weaken. We could see it erode away on the satellite. So that dry air intrusion really makes a difference. Same with a lot of moisture could make a difference. It's just a matter of where the moisture is going to be and how it's going to form. And, there's so many different factors involved with that.
Yeah, it's interesting. The bigger the storm, the more it's capable of pulling in dry air. If dry air is around, that's why you see some of these monsters Katrina and Rita, there were 5s and hit as a 3. But this goes to my little pet hypothesis of distortion of temperature, global wind oscillation, sea level pressure patterns. I've showed this, I've got PowerPoints on it showing how things have basically changed since the advent of warming, and the real advent of warming started coming on with the sea surface temperatures in the 90s. I have looked at the 1951 to 1960 versus 1981 to 1990. No perceptual change in sea surface temperatures. So what happens is when these hot spots started going off in the Pacific, I started, what the heck is causing that, right? So I'm, in my travels, I start meeting people saying, have you seen this? Have you seen this? Have you seen this? And I formed an entire hypothesis behind it that since the increase in underwater volcanic activity began in the early 90s, that in turn has been warming the deep levels of the ocean up. Eventually that has to come to the top. And I think some of these Super Ninos are the buildup of that. And then boom, the Super Nino appears. Saw it in 97, 98, 2015, 2016. All of these release immense amount of water vapor in the air. Bang, go to your saturation mixing ratios. Where does water vapor correlate to the biggest temperature differences? And then bang, you go to the Arctic temperatures. They're warming in the winter, but not in the summer, right? So if you look at, for instance, the saturation mixing ratios, this was John Kerr from Penn State. He was, always my big hero over there. Said temperature's a lousy metric. Wet bulbs are better. Saturation mixing ratios are what to look at. Well, we won't quantify the increase in water vapor. We won't quantify the increase in saturation mixing ratios, which could be argued as the same, but we will quantify CO2, right? So if you only look at one thing, the CO2 is going up, it's getting warmer. But the increase in water vapor and the way we have warmed, more in the north during its cold season, more in the south during its cold season, less toward the center, distorts the pressure patterns. Now, what happens, folks, if you pull, let's say in a normal world or so-called normal world, you're supposed to have the most upward motion over the tropics. Well, why? It's warmer, right? So the air goes up and we know what the Hadley cell looks like. What happens, and this is where Dr. Willie Sue comes in. He says, look at this. What do you think of this? How come the meteorological community is not looking at this? Basically, balloon measurements indicate there's a large-scale collapse of the Hadley cell. And I said, well, I don't know what to make of that. And then I started looking at outgoing long-wave radiation, which has increased dramatically in the last 15 years. And compared to the 1950s, is exactly opposite. We flipped it completely.
Right. We've covered this before earlier, Joe, but I want to give Stan
I'm sorry.
A little bit of rebuttal time here.
Well, this is actually going way back to something Sterling said. And also, as far as the volcanic causing more water vapor, all those things affect the circulation in the atmosphere. It's just too early to tell what the impact on the hurricane season will be. I just want to show these two slides because of the comment from earlier that it's not just storms getting stronger, it's the impact. And the impact is from the increase. This is from work by Pilkey and Lancy, the increase. So this is looking back at storm damage by decade, from 1900 to 1990s, adjusted for inflation. And it looks like, oh my gosh, it's getting worse and worse and worse. Then you go to the next slide and you adjust it for, I didn't change my slide, so I got to look at what I'm showing. But you change it for population and monetary value along the coast, and it changes everything. And it shows that, yeah, in fact, we had some worse ones. So you just have more people in harm's way. Why was Fort Myers damage last year so bad? Because, there was a lot of stuff right there on the coast that got impacted by storm surge. It wasn't stronger than other storms, but the stuff was right there in harm's way. So I just want to show that from the earlier comment. All right. So we're getting it towards the end of the normal show here. So what I want to do is I want to give each Stanley and Joe a quick elevator speech, kind of an ending, and then we're going to get to questions from our viewers. So Joe, go, 60 seconds.
Well, just for Stanley, could you imagine if Hurricane Hazel came into Myrtle Beach today? With the difference between Myrtle Beach and 54 and what it looks like now. Yeah. No, I think that I personally believe the warming that's taking place is making it, I'm not going to say easier, but revealing some things to me that I couldn't see when it was colder going on in the atmosphere. Because I always used to wonder when my father would say something to me, I go, what the heck? What was going on then? How come I couldn't see it then? And now I see exactly what he was talking about. I do believe that the greatest threats, like Stan, we've been saying this in Weather Bell, in close development within 2 days, because that's where the atmosphere can focus best, especially if you have all these cool air masses. I mean, think of Harvey, how cool it was across Texas, and very cool air into the central part of the United States during Michael and so. You need some of that going on. And if it's just warm all over the place like it is now, chances are the storms are going to spread out and they're going to move slow, and they're going to develop fairly far north. And they will also have a rightward component because of what's going on to the south due to the El Nino with that big ridge, that west-east ridge in the anomaly charts is just plastered from 10 north to 10 south.
Okay, Stanley, 60 seconds, go.
And I'm timing myself. So first of all, I'll say we're in the peak months of the hurricane season. Please be ready and stay ready. Check your preparedness. Don't wait till a storm is 2 days away from you to run out. We want to fill our gas cans now. We want to check our generator now. We want to do other preparations. So please, and there's lots of preparedness tips at the Hurricane Center site. I encourage people in harm's way to look at hurricanes, it's plural, hurricanes.gov, 2 or 3 times a day at this time of year. Get to know that site. And by the way, they just updated the information on the system in the Gulf. You change from yellow to orange for short term. It is starting to organize better. And sometimes it sits down there for a few days and then moves to the north. So we really have to watch that system. The other thing I'll say, I personally, with all my research, and I am a hurricane climate expert, see no evidence for any measurable impact of long-term man-made climate change in the storm activity. Lots of reasons for that. You can look at the talk I mentioned earlier, bit.ly/Goldenberg Orlando, all lowercase. Thank you.
You're quite welcome. And I would think that last statement by Stanley, Joe would also agree with that there's no evidence whatsoever.
One could argue the stretching out of zonal potential energy would decrease it.
Yep, exactly. Okay, so let's get to questions from our viewers. We've got a few, and hopefully we can answer those. I'm going to leave it to Andy to pop up the first question. If it's not too off topic, this is from SRB. Could you briefly explain how you calculated integrated KE for a hurricane?
Oh, great. Thanks a lot. Not my particular study. That was from Mark Powell. I think he came up with it originally at our place. But you're let's say it briefly. You're adding the kinetic energy, which is dealing with the speed of the wind and stuff. You're adding it per space over the whole hurricane area. So for instance, if you have hurricane force winds that stretch out 100 miles versus a storm that's very tight and the hurricane force winds only stretch out 30 miles, the 100-mile one is going to have much, much more overall kinetic energy. And by the way, where that really came up was Hurricane Katrina in 2005. It had been a Cat 5. It reduced to a Cat 3 at landfall. I was actually flying it at landfall, and we were shocked by 30 feet of storm surge. That was more than we get with the Cat 5. And we said, what is going on? And someone looked at IKE, integrated kinetic energy. You say, well, it still had so much energy spread out over a large area. It was able to push that water up there. So that's
all right. Next question.
Best answer I can do. Go ahead.
I like that.
Cool. Let's bring up the next question. Miles Schumacher asks, are there any thoughts about why there seems to be a disconnect between the sea surface temperatures and atmospheric coupling with El Nino so far?
Yeah, I tried to say that with this distortion of the temperature and pressure pattern that's going on. When it's warm all over, the pressures are lower to the north than they should be. And actually, that actually stops a lot of these things from being sheared off. Because think of what happens is part of the big thing with if you go look at every single El Nino season, the Atlantic is usually normal to below and what Stanley's main development region there, right? So what does that mean? That means if there's lower pressures to the west of South America, higher pressures than normal in the Caribbean, bang, you create strong low-level easterlies. Even if the 200 millibar levels are normal, that's still increased shear. But again, it's kind of frustrating being this little guy over here in State College, Pennsylvania, because you try to show this. Look at these pressure patterns in June and July across the Atlantic. Compare them to 2005, 2017. Look nothing like 2005, 2017.
Right. Stanley has a comment.
In the atmosphere.
Yeah, I've got the latest statement from Matthew Rosenkrantz, who's the head of our seasonal outlook team from CPC, Climate Prediction Center of NOAA. And he says this: the winds from El Nino are starting to build in over Central America. And that's the upper level winds. El Nino tends to generate, without going into all the details, increase upper level westerlies, winds from the west, which increases vertical shear of the Atlantic. So it's starting to encroach, as he said, as the upper level anticyclones are starting to establish for the Pacific in response to the sea surface temperature shift in El Nino. So there is starting to be an impact, and it might have more of an impact as the season goes on.
All right. Next question. John Z, you guys need a YouTube channel. Call it the Stan and Joe Show. Yes, that would be 24/7, 365.
Well, we're actually launching a podcast over here called The American Storm. That's and I've got actually.
Well, you should invite Stanley on so you guys.
I would. Oh, he'll be on in a heartbeat. Yeah, because most of the stuff that I know comes from guys like Stanley. Listen, the only thing I know is the Apostle Paul said it correctly. Those who know what they know don't yet know what they ought to know. I just live by that kind of thing. And so what happens is the more you look at this.
I thought that was Rumsfeld that said that.
Well, maybe Rumsfeld said it too, but Paul was before Rumsfeld. But the fact is that all these people have come before me. All these people that have come before me, I can't even believe how good they were. I mean, it's one thing with all these models we have today to make a forecast, as opposed to the guys that are making forecasts back in the 40s, 50s, and 60s, those typhoon forecasters in World War II or the Normandy forecasters. I mean, I'm like, geez, I can't compare to those people. So all these, Stanley's a little bit older than me, plus he's into research, so he knows more than me. So what I do is I simply go read everything they say. And, if I have a little bit of a disagreement or a little hypothesis, I think we can still put that forward. At least
forecast is still very much a skill, which is something that people don't seem to understand about computer models. It's impossible sometimes to take the skill that people have, the pattern recognition, those kinds of things, and put those into computer models. Computer models are all about equations and so forth and variables. The skill, it does not find itself entered into computer models very well sometimes. And that's why we still have huge failures of regular forecasts just a few days out.
Chaos.
Because the skill's not there.
Let me tell you.
Computer models can't account for chaos.
Yeah. Let me tell you, when you talk about models, when we had the 30th anniversary of Andrew, I look back and where are we now versus 30 years ago, which was 10 years after I got started. And it is amazing with the advance in some of our computer forecast models and other stuff and the better data that the 120-hour forecast now, track forecast, is as good as the 48-hour 2-day was 30 years ago. That's huge improvements. And we're starting to see some. I've worked with some of the main hurricane forecast models, and we're starting to see some improving the intensity forecast as well. So we are coming a long way, but I'll tell you, it's still a model world versus the real world.
Here's a really simple question that I'm sure either of you can answer. Math Kimboss asks, why are most hurricanes above the equator?
Because they occur away from the center of the Hadley cell. You've got to have some kind of resistance to try to.
Actually, I think what he might be asking here is why are they mostly in the northern hemisphere?
No, they're a lot in the southern hemisphere. They occur in the southern hemisphere too.
Right, I know, but aren't the majority of hurricanes
there's more
in the northern hemisphere
because you have larger areas of warmer SSTs, sea surface temperatures. The West Pacific is the preponderance of the activity, and that has this huge span of warm sea surface temperatures, and you have to have the seedling systems that actually generate that. So you just have more favorable. In the South Atlantic, we had a rare storm, but you don't have as much of an area. You don't have the easterly waves. There's all sorts of climate reasons why you have more to the north.
All right, we have one final question, and we're going to wrap up. Christine Laurel asks, what is driving that increase in underwater volcanic activity? Well, we have no volcanologist on this show.
Well, hold on a second, because this is really into what I'm doing right now.
If you say HARP, I'm going to shut you off right now.
With Dr. Vittorino and Dr. Kim, but when I was at Heartland, and Moncton was there, and we were talking about this. Moncton is like plays 15-dimensional chess. So he goes, okay, well, what's causing that? And there is some theory out there that the reversal of the core of the inner core of the Earth, is a reversal taking place, is putting undue stress on the bottom of the oceans, and we're getting more seismic activity. All right. So when I said that to Moncton, he goes, okay, well, what's causing that? And he started tracing it back to, as I understand it, because he started tracing it back to gravitational pull from the planets and things like that. I could give you the Bill Gray answer because it is.
Yeah, I know what you're talking about, but you're totally wrong on this. Totally wrong. It's climate change that's causing it, right?
Man-made climate change.
Anthony, that back radiation that penetrates a millimeter or two of the ocean is what is causing the ocean to warm right there.
There you go. There you go. All right. So that pretty well sums up our show for today. I want to thank Stan Goldenberg and Joe Bastardi both for being on. I want to thank Linnea and Sterling for suffering through the silence. And
they smiled a lot, though, especially in
It's okay. It's okay. I want to thank everybody for viewing. I want to remind everyone to visit nhc.noaa.gov, one of the few NOAA websites that's not taken over by global warming mania and gives you accurate facts and accurate projections. So go there for hurricane information. Visit weatherbell.com for some of the most fantastic forecasts on the planet. climaterealism.com, climateataglance.com, and energyinaglance.com are all part of should be all part of your daily repertoire for fighting back on climate alarmism. So I want to thank everyone again and say, this is Anthony Watts, Senior Fellow for Environment and Climate at the Heartland Institute, wishing you a good day and a great weekend. Bye-bye.
God bless all.
How dare you!